Okay, hi everyone. Thanks for coming here today, and thanks for tuning in. My name is Jeff Cardille. I'm a professor at the University of Montreal in the geography department, and I'll be talking with you today about a master's project that we have just finished up in the last few months called GeoSearch, which is a new virtual globe application for the submission, sharing, and visualization of point-based ecological data. The work that I'm presenting here is not really so much my own as Rodolphe Gonzalez's. He's a student who was co-supervised by Lael Parrott, my colleague in geography, and myself. And Rodolphe really is responsible for both conceiving of, developing in most of the cases, and managing, in addition, the work that you see here. There are also some huge contributions by the people you see on the right side of your screen there. Gail Deist, who did database development, Caroline Gaudreau, who did interface work, Benoit Belanger, who gave us the ability to introduce data to our network, Casey Brown and Jean-Francois Marsan, who came on in the last few months. And of course, all of this is built on the development done in Google Earth and Google Maps, the Prefuse library of visualization technologies, and Whirlwind. I mentioned there also the students of my course 6352, which I'll talk about for a few minutes at the very beginning. So this is the first time I've ever been recorded, I think, for a talk in my life. It's for sure the first time I've ever been recorded for YouTube, and as a result, I've gotten lots and lots of advice from everyone from our babysitter to people at the daycare. My wife has some ideas, my mom has some ideas about what I should do, and they center around trying to make the video viral. So I've had suggestions to wrap the entire presentation. So if I had some good rapping skills, that might be something we do. Also, animating a dancing baby seems to be a very popular way to get a lot of hits on your site. Let's see, anything with Star Wars in it seems to be quite popular, whether it's waving a sword around or making my own videos. And of course, anything that has to do with evolution of dance. So if it were possible for me to do evolution of dance, perhaps combining that with a Diet Coke and Mentos, while rapping, possibly having a dancing baby rapping the Star Wars theme while dancing around and doing our Diet Cokes, that's what I would do. So I'm not going to do that for sure, but the main advice that I got from everyone is to be yourself. So hopefully some of that will come through during this talk. Okay, so as I say, we'll talk about the course, first of all, because that really is the source of all of the work that you see here. And then second, talk about GeoSearch, the globe-based data browser. Third is the Sustainable Forest Management Network social network browser, which we developed as part of this package. Third, looking at project locations. And fourth, looking at journal article study sites. So I mentioned this course because really it's the foundation for all of the work that you see here. It's a practical graduate seminar that I developed when I arrived at the University of Montreal 3 years ago. And this seminar focuses on the capabilities and the recent developments in Google Maps and Whirlwind and Google Earth. I mentioned that it's a practical seminar. And the reason is that we have a practical component. It's one of the few graduate courses where we have a lab, 3 hours in lab each week. And some of the labs that we've developed for this course, you can see they're written on the screen. We have 2 for Google Maps. Introduce the students, these graduate students, to My Maps and shared editing. In the earlier days of the course, 3 years ago, there was no My Maps, so that lab in particular has changed quite a bit. Second, you can see 3 ways to embed your map on a web page. Students learn that in their second or third week. Then we have a second module. The students do a project, a small project in Google Maps, making a mashup of some sort. For the second module, we look at the introduction to Whirlwind. We've developed a lab for that, looking at the New Orleans data provided by the Whirlwind system. Data with Whirlwind, looking at web mapping servers, vector and rectified raster data. And that's for the Whirlwind component. For the third component, looking at Google Earth, we have written labs looking at KML and Google Earth. And in particular, in that one, what we do is we have students pick apart an existing KML file. The KML file that we used is one created by National Geographic for elephant poaching several years ago. It's got a real wide range of things that KML is capable of doing. And so students pick that KML apart, change it a little bit for their own purposes as part of that lab. You can see the other labs there as well. We have one on Yahoo Pipes and Google SketchUp. And that's the practical part. For the seminar part, you can see here that the students collaborate throughout the semester by annotating websites, annotating blog postings, talking about mashups that exist, and looking at the various cutting-edge things that are done with Google Earth, Google Maps, and Whirlwind. As I said, it's a grad seminar, and so students bring the material to this course. So for example, in the first week during the morning session, the students are asked to look on the Google Maps Mania blog for examples of mashups related to Canada, 100 things that you can do with Google Maps mashups, Google Maps Mania special features, for example, social networking using mashups. And what they do under a common user, the students create a very extensive Google notebook annotating all of the newest things that they have found and brought to my course, to our course really, because they're the ones bringing the content. They bring this stuff, we talk about it for 3 hours, it catches me up very quickly, and it allows them to learn, I think, much faster than if they were simply listening to my lectures about what I think these technologies can do. So it's a grad seminar, and everything is online using lots and lots of Google technology things. All of the student work, as I say, there's hundreds of sites now that are explained in Google Notebooks, one for each of these 3 technologies. All of the students' reports for the labs and projects that they produce are in Google Documents. The student presentations themselves are in Google Documents. So there's no trading of USB keys at the beginning of the class. They simply do their, upload their presentation or work on their presentation directly in Google Docs. And we look at them together through the internet connection in the department. So, the syllabus is at Google Sites. If anyone hearing this is interested in looking at that or adopting it, or in fact just taking the syllabus and doing it for a class of your own, you can feel completely free to do that. The labs are in Google Documents, and all of the data is available, which is a really nice thing for teachers who are interested in teaching in a practical way these abilities, these technologies. It is in French. It's a French-speaking university, but Google Translate does a great job of translating my broken French and the students' fantastic French into any number of languages. So as I mentioned, that's a course that I do, and it really is the thing that underlies this project that I'm about to describe to you. The reason is that the TA for that course is this same Rodolphe Gonzalez, who had come to me when he heard that I was shopping around the idea of a course. He came to me and said, I know a little bit about Whirlwind. At that moment, I had never heard of it. He said, Google Earth, I know you can do things that are more than just looking at your house. I thought that was a pretty neat thing, so I took him on as the TA. And then soon after that, I was approached by the Sustainable Forest Management Network, which is funded by NSERC, the National Science and Engineering Research Council of Canada, which is somewhat like the National Science Foundation here in the United States. So this Sustainable Forest Management Network is an umbrella organization of forest research. And what they have done for the last 15 or 16 years is they have created projects, given money for projects, science projects, done on the general theme of sustainable forest management. And yet, at the end of their time, at the end of this 15-year period, decade and a half, they have I would say, very limited access to the data that has been gathered as part of their management network. At the beginning of this, that goes back to the early 1990s. Internet sharing was a pretty rare thing. Projects were probably not even done in PDF, I would think, project reports, going back all the way at the beginning of that. And so there's very fragmentary evidence of this network and the data that this network had gathered. So they came to us with 4 big questions, and those are the 4 components that I'll talk with you about here today. So their first main question is, where are data samples located from all of the work that we've done on our research, and what are their values? Second, the basic question of who worked with whom in this network. After a 15-year period, it's possible to reconstruct who had worked with whom and what they had done. Third, where were projects located and what were their results? And fourth, what journal articles were created through this network? So the answer to the first question forms the title of this talk, GeoSearch. The main question there is, where are samples located and what are their values? Our goal is to create a set of programs, or to really adapt a set of programs that take advantage of these emerging capabilities. So what you see there on the left, on the upper left, is a globe representing Whirlwind, which is the virtual globe that we embedded this data on. Second in line, the gray form that says by province, is a really amazing set of Java libraries called Prefuse, which is data visualization techniques developed at the University of Berkeley, if I'm correct, by a PhD student for his PhD work. And the third represents databases. So what you can see here is our Whirlwind, our GeoSearch application in action here. can see just the basic ability to move the globe around. But I think what is really the most interesting about this particular component is the ability to move through this network of information down on the bottom using this prefuse database, this prefuse set of libraries, sorry. So you can move around and select information such as, I think in this case, lichen cover and other forest information, show the two of them together, and the two of them are displayed together, these two variables, herbaceous cover and lichen cover, on the globe. It's possible to move around, zoom in, and do all the various things that you're used to doing, with the addition of this neat feature of being able to view in the third dimension of the globe the fourth dimension of time as represented in the data. So we elevate the individual points to an elevation that represents the date that they were collected. So data from 1992 is lower than data from 1997, which is lower from data in 2008. You can see the large black bar in the middle that the cursor is moving across there. And what that is doing a selection of data from a particular time. That's a timeline. So as you can see, there's data at two basic elevations shown in the figure there. And so that's data selected from the left side of the time diagram. And on the right, the eastern part of Canada, I think, is the data from the other period. So here's a little bit of a closer view of what that data might look like if you were to look at it with this mocked up data here. And this represents the change in two variables. In this case, it's dissolved organic carbon and dissolved inorganic carbon, taken from a carbon simulation model simulating the development of carbon in lakes and its changing concentration throughout the year. And what that represents is the months of January to June, on average, in these two particular lakes. So that's the combination of these three technologies in one, built from Whirlwind Java, prefused libraries for moving around through the data, and with the database built from Postgres SQL. So in this first go-around, this first draft, that's one of the main things that Rodolphe produced as part of his master's degree. And it's, I think, important to realize that it's pretty amazing for a master's project to have done something that's really pretty impressive, capable of taking in this data, or capable really of displaying data that's already been taken in. So data entry for us at the beginning was not the main focus. We were really focused on visualizing this information. And so data entry, until just a few months ago, in fact just a few days ago, was very difficult. So even though theoretically we could get data into the data set, into the database, the shared database, it was quite hard for anyone except a real experienced administrator to get data in. So what we did was we went back to a project that I had begun when I was a postdoc at the University of Quebec at Montreal to do the same kind of thing, but in a I think a pre-Google Earth period. This is in 2005. We looked at trying to find some way to share information among the lake researchers in this inter-university group of research in limnology being the study of lakes. So we had a large amount of information. This is another much smaller network made of Quebec scientists who gather information about lakes. And like the people in the forest network, their data sits in individual Excel files on their computer. And those computers get old, the formats change, and the data basically sits as individuals and rests as individuals. What we had looked to do, and what we succeeded in beginning at least, was to create a framework for people to upload data to this shared database. At that time, there was no shared globe ability. There was simply the ability to upload data to this common database and do a simple yes-no search with a few ranges in order to extract data. So this was a data introduction and data storage and data extraction tool. And that's where it's at for several years until just a month or two ago. What we did was to take that and basically graft it onto the Whirlwind based GeoSearch application that I told you about just a few minutes ago. And so now we've introduced the ability to have easy uploading of data. You can add sites. We changed it from being lake focused into being able to gather information or accept information for any sort of point-based site with the latitude, longitude, and site name. You can also add data. The system has a pretty sophisticated parser for understanding the different names that people can call the same effective bit of data. So in Quebec in particular, where English and French are both spoken, I might call something dissolved organic carbon, but the French acronym for that is not DOC, but COD. And so this system allows for that ability to switch back and forth, or to, in effect, to interpret intelligently what it is that the user is trying to input by asking a pretty smart series of questions and building intelligence over time in what data rests in the database. In the last few weeks or so, I guess, we have introduced the ability to do a simple search in Google Maps. You can see that on the right side of your screen. And by choosing among the data sets, we can click on that little check, or not checkbox, but the little menu item that says DOC. When you do that, a slider comes up and it allows you to move back and forth between the different values that you might want of DOC to pull out of the database. So in this case, the user has slid the sliders left and right to ask for data between 2.8 and 10.2. And when they hit refresh map, they can see where the samples that fit those criteria were selected in this data set. Meanwhile, that data exists in the three-dimensional browser in the virtual globe that you saw as well. So that's the first of our 4 driving questions. For the next 5 minutes or so, just maybe 6 minutes, I'll tell you about the following 3 in pretty quick succession of detail. So second, who worked with whom in this network? That's another basic question that the Sustainable Forest Management Network was interested in reporting, or in recording. And they asked us if we were capable of keeping track of that. And in fact, we were. Here you can see a very roughly animated view of the network. I'll zoom in on that in just a minute. And what that shows is sort of in a constellation form, shows who has worked with whom. There are hundreds of researchers shown on this slide that you see there. And I'll tell you about the panels that you see on the right in detail in just a minute. What this allows us to do is to basically click on individuals and see the network from just their perspective. So in this case, I've clicked on this person, David, and we can see all of the people who he has worked with. Depending on the version of the software, we can allow it to look 2 levels deep or 3 levels deep in order to see who the people worked with, who he worked with. And we can basically move through this network, changing the perspective of, seeing the network from the perspective of individual researchers. And so what you see here on the right is what this thing looks like in action. The prefuse library moves people around, moves their nodes around based on physics principles, I think, if I understand it right. You can still interact with the system, though, as it's doing that. You can move back and forth. We can click and move between individual researchers and see the network from their perspective. So again, this is the Sustainable Forest Management Network social browser, so it allows us to see who these individuals are and who they have worked with. We also have a feature there on the left in the middle. You can see it's called a business card. It's a bit hard to read with this particular color that we have for people who work, I think, in the government in this case. So you can see the color of the nodes, and the color of this business card represents where they came from and who they work, their basic category, whether they're from academia or non-governmental work, or industry, government, Aboriginal, or if we didn't have the information, we gave them, I think, a gray color. So the point here, though, is that you can click on the business card and learn more about the researcher. So when you click on the business card, what we do is we issue a very standard Google search, searching for the name of the researcher who you've clicked on, and their university or their organization. I think we also enter forest management as well. And that gives us, as any great Google search does, it gives us a long list of links, some of which are more relevant than others. In this case, just getting ready for this talk, I was able to learn quite a bit about this particular researcher, Dr. Ed Johnson, and not only the project that he had worked on and his main homepage, which was the first list, but also this really interesting ecology education project that he works on as well. So it's possible to learn not only what they have done in this particular forest network, but more broadly what it is that they've worked on. This is, again, Java using the prefuse library with a thing called a tree ML, tree markup language. And it's basically set up to say David works in academia and Jane works in academia, David works with Jane and Jane works with Jim, and from that is produced that large network that you see. So that's the second of these 4. I'll move real quickly through the last 2. So we also are curious where projects were located and what are their results. Well, there is a reporting requirement, and was a reporting requirement in the Sustainable Forest Management for producing project reports. But those project reports were mainly, they're basically stored on their server as project PR-145-2004, and they're really pretty hard to get to. So what we did was to produce this KML that's suitable for looking at in Google Maps that shows us where the study sites of the sustainable forest management projects were. And this is a real simple thing done with about 100 hours or so of an undergraduate technician's time reading project reports very, very quickly and trying to pull out the relevant information to show them on a map. When you click on it, we use the Google Spreadsheet Mapper to show in a real nicely formatted structure the main information that we had found in those project reports. So you can see here's the title of it, who the authors of that project were, a little excerpt from the beginning. You can also click on the PDF of the project report, which takes you into the window in the database that's currently managed by the Sustainable Forest Management Network. And we can also do a Google search like you already saw for the individual researcher. So the way that this was done was actually quite simple, and I'd encourage other organizations to do this. It didn't take very long at all. What we did was we went to the network's website and downloaded 200 or 300 project reports, and then read those reports, looking for maps of the study sites, or looking for, as you can see there in the methods section, it says the 8,000 square kilometer area was located in Prince Albert Provincial Park at the following latitude and longitude. So that's where we located that project to be. We then pasted the executive summary and some other interesting things, pasted all that stuff into Excel in a very carefully formatted way, because the goal was to put it into the Google Spreadsheet Mapper. If you know what that does, then you know it's really pretty amazing. If you don't know what it does, what it allows you to do is to create these nicely structured info bullets that you see in the left. So we took them from the Google Spreadsheet Mapper, produced the KML file, stored that KML file at Google Sites, and that KML file is suitable for introducing into Google Maps by in simple ways that you could, I guess you could read the labs for the course to do that. You can also look at it in a typical way in Google Earth, and also we're probably going to embed this on the main data server in a few weeks. So that's how we located where projects were, which is a big advance over where things had been, the way that things had been stored in the past at the Sustainable Forest Management Network data site. Finally, I'll talk about what journal articles were created through this network. That's one of the big measures of the success of a large, long-term network like this. And what we did was we took a slightly different perspective for this. Again, we scraped through the information that we could find at the network site. But in this case, we created a collaborative mind map. And I'll tell you more about that in just a second. You can see the letters of the alphabet there floating in the bay in the northern part of Canada. And that's a false location. That's just designed for individual researchers to be able to grab their letter, the letter that represents their article, and drag it across the country to where the study site was. Because we read the articles, we knew where the sites actually had been, where these articles had been done, but we wanted to introduce this idea for researchers of the ability for them to interact with this over a long period of time. We currently have it stored as a public map. It's been viewed many thousands of times, which kind of surprised me when I noticed that. But it seems like it's a useful doorway into this work that has been done. So when you click on it, you get something similar to what you've already seen, with the addition of the little item that says Search for Article at Google Scholar. If you click on that, you see the results of the Google Scholar search, and that gives, of course, not only the article itself and access to the article, if that access is warranted, but also articles that are related. So in my case, I was able to use this to find several articles that were really interesting to me on a couple of different topics. So the way that was done is quite similar. We went to the network website and looked at this PDF bibliography of articles. It's just basically a statement of the articles and their citations of the articles that were done over a 5 or so year period. Put that through Google Scholar, found those, made an EndNote database, read all of those articles. Again, Jean-Francois did an amazing job of that. Put them into Excel, took them through Spreadsheet Mapper, but then imported that KML into My Maps that now is editable by people who have the password for this particular map, so authors can move their points around. So to summarize, there are 4 main things that I've talked about here. The first is our approach to looking at data samples, where data samples are located in this for me, large, but depending on the scale, medium-sized network of science research, where those samples are located and what are their values. Second, who worked with whom in this network. I think there's a real neat solution to that that also gives additional value for being able to find the researchers in the network. And third and fourth, these location-based ways of interacting, or at least viewing the database of project locations, project reports, and journal articles. So like a lot of projects, there are a lot of limitations to it, I would say, and several things that we really hope to do with it in the future. The limitations are substantial, I would say. It's a first draft of nearly everything. So the programs crash from time to time, not the Google Maps part, but the work that we've done on the globe and moving around between previews and the globe works pretty well. But at the moment, it's still download only. And so we'd like to take that and eventually make that into an applet and store that on a web page so that we don't have to encourage users to download a new version every time we correct a few bugs. I would say also it's not quite yet ready for massive scale up. There are some things in the design that we would like to change, and we'll be doing that in the next first few months of next year. So we're interested in partners, whether it's organizational or just individuals, to try to think these things through. As I said, this is basically one student's master's project, and it's an extremely ambitious project that I think was really successful. And so, for example, we'd like to find out how we should best make this transfer between the server and the client to be not just downloaded all at once, but as needed. I know Google Earth does that really well with their tiling, and so we may try to adopt something like that as well for ourselves. We're also interested in anyone who hears or sees this and is interested in testing the usability of this system. This is basically done as a group of 5 or 10 individuals making their best decisions, and also any creative ideas on next steps. So you can see the link to the website where you could learn more about this if you're interested. And just to summarize again, the idea here is talking about this new virtual globe application for submitting and sharing and visualizing our point-based ecological data. Again, this is the work mainly of Rodolphe Gonzalez, who we co-directed, Lael and I. And there's a lot of work that is buried in the details here by Gail and Carolyn and Benoit and Casey and Jean-Francois. So again, thank you very much, and I appreciate the time.